Hello, everyone. My name is Ali Mustafa. I hope you're doing good. Let's wait for a few minutes and let's welcome all of you. Hello, everyone. My name is Ali Mustafa. Okay, we see a few people already here. That's good. Hello, David. Okay, you're here. That's awesome. Yeah, you can put in your name. Hello. Okay. This looks awesome. We will be starting at, we'll take a few minutes pause and then we will get started. So we'll probably start at, 504, somewhere around that time, once everyone kind of has joined us. So, yeah, till then, if you're here from different cities or if you're, you can just introduce yourself or give us a thumbs up in the chat or say hello. That is also fine. So, yeah, just interact in the chat. I already see a few comments up there. So yeah, that is good. Awesome. Yeah, please join in and also invite your friends as we are kind of almost starting off with the session. With the session. Hey, hello, Saurabh. I hope you're doing good. Yeah, I'll be shortly starting up. Yeah, just wait for a minute or two, and we will get started. Till then, you can type in, where you're from, and yeah, I would be really good. Awesome. So let's get started as other people are joining. So today we are here for another session on TensorflowJS. My name is Ali Mustafa, and I'm the organizer of TensorFlow User Group Mumbai. TFUG Mumbai does a lot of sessions around TensorFlow and machine learning, and kind of educate developers around the TensorFlow ecosystem. And today we are back with TensorFlowJS as our main topic. So today we have Shivay with us. Shivay is the CTO of Darkhouse and a dedicated engineer with good experience, in terms of machine learning and to solve real world problems, real world challenges. He's highly skilled in full stack development and is also a Node.js, ReactJS, and AWS developer. He has been, involved in TensorFlow a lot and has used has kind of delivered multiple sessions across it as well. So today he will be kind of covering around TensorflowJS and introducing WebNN as a backend for TensorflowJS, and it is a very exciting talk. So I hope you all enjoy it. As I'll definitely share and try to gain some insights from Shivai. So Shivay, let's welcome Shivay. Shivay, over to you.
Hi, Ali, and thank you so much for inviting me over for this session. I had been longing for a long time to have a conversation with you, and it's really great to share the stage with you. And again, thank you so much to the entire, TensorFlow group, user group, Mumbai team for actually inviting me over. And I have actually been following all the different Tensor user groups, right? TensorFlow user groups, and definitely like the kind of events that especially the user group Mumbai is actually doing. It's quite phenomenal. I myself, I am sort of a co-organizer for the TensorFlow user group Delhi. So it's really good to see all the initiatives that all the user groups are, sort of doing for the machine learning communities and helping, more and more people get introduced to the newer things that we're having with TensorFlow ecosystem. So yeah, I mean, really excited for today's talk as well.
Awesome, awesome. Yeah, thank you so much for your kind words. Firstly, I've also been kind of
Yeah.
looking at what you're doing in the community, and it's amazing, great work out there. So yeah, very excited to hear you out, and yeah, the stage is all yours.
Absolutely. Thank you so much. So I'll just start by sharing my screen first. So let's see. All right. Thank you so much, everyone. And again, if any one of you have any questions, feel free to ask them in the comment section, and I'll be more than happy to take them up, in the later stage of this live stream. So today we have a sort of a very interesting topic because it's something that is still under development as we are speaking. And it's something that I'm personally really excited for, especially for the TensorflowJS ecosystem. So, just to give a very quick introduction about myself as well, I am a TensorflowJS SIG and working group member, and I have been actively advocating about TensorflowJS, especially in a lot of student communities at hackathons and also in a few conferences. And I was a Google Summer of Code mentor for the TensorflowJS project, especially working towards the backend WASM side in the year of 2021. And previously, I've also been a TensorFlow mentor for Google Codin program. Now, of course, I mean, probably this particular audience for TensorFlow user group Mumbai might be quite familiar with TensorFlow.js. So today's talk is not really going to be, like TensorFlow.js 101. It's more sort of specific towards a particular aspect of TensorFlow.js. But just for a quick reminder on what exactly is TensorFlow.js. So TensorFlow.js is a open source machine learning library that is initially started off as a project known as deeplearning.js that enabled you to basically use GPU accelerated power to actually run machine learning models on the web. And back in 2018, it is finally merged with the ecosystem of the various TensorFlow projects that we today have, and got official support by Google and was introduced to everyone in 2018. And ever since then, TensorFlowJS has grown on to be the most, you could say, the most widely used machine learning library for web, right? And of course, we know that today JavaScript is one of the most powerful and one of the most used, like programming languages. And the kind of support that we have, the ecosystem of JavaScript today not only is limited to browsers, but also you can run it on the server side with Node.js, on desktop by creating desktop applications with Electron.js. On mobile, it has support for things such as TF Lite, and also with React Native. And also, I mean, we have support for IoT enabled devices with Raspberry Pi running Node.js as their backend. So that just goes on to showcase that how much prevalent JavaScript today is, and it just makes sense that we can really use the powers of machine learning to combine with JavaScript and just make machine learning available across so many wide range of use cases. And today TensorFlow.js is not just limited to something that you might be doing on a personal project. Today TensorFlow.js is really being used by a lot of different companies in a lot of different startups. A lot of different mainstream applications are using the power of TensorFlow.js, right? And just quickly going into the largely into understanding the ecosystem of where exactly we are today with TensorflowJS, right? So just understanding the architecture of what is actually happening behind the scenes. So we have these various layers of abstraction that goes on, right? So at the top we have our pre-built models. So if you might be aware, or if you might have seen some of the previous sessions that we had on TensorflowJS, one was taken by Karthike just last week. We essentially have three different ways in which TensorflowJS actually works, right? So the first one is that you have your pre-built models that are directly usable in your browser. You can directly embed them in your TypeScript or your JavaScript code and start using them without even knowing what exactly is going on behind the scenes. The next one is transfer learning, where you're using a pre-existing model and then training it on your own data. And then once you have trained it over your own data, essentially what is happening now is that you can customize that model based on your own use case. And the third one is that JavaScript allows you, or at least TensorflowJS allows you to write your own machine learning models. So either you can have your research done in Python and use like a Python based model and then convert it into a JavaScript model using TFJS converter, or you can also use saved models either from Keras or TensorFlow and then use them. Or today we also have direct support for actually using the models that have been built in Python to be directly used in Node.js, right? That you can directly use these models in Node.js, or you can actually write your own machine learning models directly in JavaScript as well. So depending on the layer of abstraction that we have at the top, we have our pre-built models. Then we have basically the layers API that sort of gives you abstraction like Keras, where, for example, on the Python side, Keras has been built on top of TensorFlow, and it provides you some easy to use functions that you can directly use. But if you really want to go deep into actually being able to edit or being able to manipulate the linear algebra or the mathematics involved, you can basically work on the core slash ops API as well. And currently we have support for two different ways. One is the client side and the other one is server side. So when you talk about the client side, that means being able to not only train your machine learning models but also run the inferences directly on the browser. So client would also not just be limited to browser if you're working on the web, but also on things such as React Native if you're running your machine learning models on like a mobile application. So on the client side, we essentially have three different ways, three different environments. So you can directly run it on CPU. You can use some of these backends that we have, for example, WebGL, that is sort of it sort of is a short form for web accelerated graphics, right? And then we have WebAssembly as well. So one of the previous sessions that was taken was on WebAssembly as one of the supported platforms to run inferences of machine learning in TensorflowJS. But of course, what these CPU, WebGL, and WebAssembly, these are not like specifically server side, but essentially what it allows you to do is use the native performance of your CPU or of your GPU that you run on your device to actually run and power these machine learning models that are running directly on the client side. And some of the benefits of running these machine learning models on the client side include more privacy. It does not, it saves you the cost of actually sending the model details, or let's say all the inferences, to a remote server or to a dedicated server. Everything will happen directly on the browser. Or you also have the server side, where you can basically run these machine learning models directly in Node.js with the TF CPU or the TF GPU bindings. So today, what we are more focused towards is essentially understanding the various type of backends. Again, this is not the server side. This is what I'm talking about is the client side, right? So essentially, we have five different ways today that we can sort of use, and these are specific backends that allow you for running your machine learning models from training to inferencing, and running them at runtime. So the ones that we currently support include the CPU. It's sort of the slowest form of execution, right? It uses the native virtual machine that is sort of powered by the JavaScript on your running on your browser. So it is using the native inference that can be run using JavaScript, and it is always available by default. So if you're now so basically what happens in TensorflowJS is that you can set the runtime based on the program that you're building. So if you don't specify any specific runtime that we are seeing over here, it will by default run the one that we have on the CPU side, the general CPU. Then we have WebAssembly, which really works great on standard CPU execution. Today we have support for multi-threading with GPU support, SIMD, right? And these work really great for some of the smaller models. So you can specify your backend as WebAssembly, and it will take into account, or it will sort of utilize the power of the CPU and the GPU that you're running locally on your machine to actually power and run your machine learning models much more faster as comparison to in comparison to the CPU based inference. And then also we have WebGL, right? And these three are the ones that we have currently supported. These are currently live. So in case you want to actually build and run an application, you can use either of these three different backends. Now, the two other ones that are currently under development, right? The first one is WebNN, which I'm going to be talking about today, and we'll be going much more deeper into understanding what exactly is WebNN all about. And the other one is WebGPU. So both of these standards are currently being built upon. WebGPU is sort of more at a, like you could say WebGPU started before WebNN. So WebGPU is at a stage where probably in the near future we might actually see it getting executed as well. It is using the native execution from the GPU that is being powered in your system to actually power some of the machine learning models. And of course, we'll be talking about what exactly is WebNN, right? So that finally brings us to what exactly is WebNN, right? So just to give a brief background into what exactly is WebNN before we directly start with what exactly is WebNN. So we have this community called as W3C, and the W3C community, so this community is basically looking at a lot of different web standards. So a lot of the things that we are introducing today in in the entire ecosystem of web is being run by the W3C community, right? This is a committee that has a lot of different avenues, and they have a dedicated section for running or powering machine learning in web, right? So a lot of the discussions around adaptation of newer technologies such as WebAssembly have been discussed, and introducing new web standards is something that the W3C committee sort of takes into, right? So they have a section known as the W3C machine learning committee, which sort of looks into different possible scenarios, different possible ways in how we can introduce machine learning into web. And it's the committee that sort of runs the WebNN. So basically WebNN is a standard, right, that allows native web applications and frameworks such as TensorflowJS to sort of be able to actually accelerate specifically deep learning neural networks with your on device hardware. So that essentially allows you to basically use the power or leverage the power of your native GPUs, CPUs that are running on your machine to actually accelerate any kind of deep learning based web applications that you might be building. Or of course today what we are also seeing is that apart from just your native CPUs, GPUs, we are seeing some more dedicated hardware that essentially also includes things such as AI accelerators. So we have certain machines such as DSPs. These are some very specific dedicated machine learning dedicated machine learning based hardware that can be combined with your native CPUs and GPUs to sort of run machine learning based applications faster, and running machine learning based frameworks inferences much more quicker, right? So we'll be going more deeper into understanding these this WebNN format, because it's really important to sort of understand what really is going on behind the scenes with WebNN, and how is it going to be actually useful when it actually comes to machine learning in web with TensorflowJS, and how WebNN sort of comes into the ecosystem of TensorflowJS. So basically, WebNN is the format that we're looking at, and WebNN essentially provides us with an API. So we call that as the Web Neural Network API. And this API is sort of being used to basically allow us to sort of, go ahead and run hardware agnostic. So why we say that it is hardware agnostic, so basically you could say that this API that has been provided to us by the web neural network format is that it allows you to sort of use this machine learning capabilities directly from your hardware, right? And it's agnostic of the platform. So if you're running it on any specific, let's say Intel based or an AMD based or even a NVIDIA based GPU, it will be able to utilize the capabilities of that GPU and power up the machine learning capabilities in your system. So just looking more deeper into how basically this entire ecosystem sort of looks like, I'll just quickly go ahead and I'll share my screen to so I'll just stop sharing my screen and I'll go very quickly into sharing my entire window. So it gives me 1 second. All right, I think this should be good enough. If my screen could be shared again, that would be great. All right. So basically, I'll just quickly go into the WebNN, right? And I'll just explain particularly this part, right? So essentially, this is the entire underlying framework, right? So as you can see that we have not only support for TensorflowJS models that essentially includes things such as TensorflowJS, TF Lite, right? But it also comes in support with some of the other models such as OpenCVJS, ONX, ONNX.js, and various such different types of machine learning models that run with JavaScript based frameworks. And what sort of WebNN API is doing is that it's creating this wrapper, or it's giving you this framework that allows you to sort of wrap all these different models and get support from these different backends that we are currently running, including web GPU, or even for that matter WebAssembly. So WebNN right now, like very specifically what it is currently doing is um, that it essentially allows you to basically go ahead and go ahead and use the capabilities of these APIs that we have, right? So whether it is being able to utilize WebAssembly, or it is able to utilize web GPU, and then run basically the hardware capabilities, right? For example, CPU, GPU, ML accelerators are, these are special, like sort of correspondingly the more specific hardware that can be utilized with in conjunction with your GPU to be able to actually run machine learning models and power these, right? So over here, what you'll also see is some of the ones that we currently already have. For example, in the TF Lite ecosystem is the neural network API for Android. So this is actually currently being used live within TensorFlow Lite, and we are already seeing its utilization directly in running machine learning models directly in native Android. And so the idea now is that how can we introduce this WebNN in something like TensorflowJS as well. So as we just mentioned, so far we have had the support of running backends such as WebAssembly, WebGPU, WebGL, right? And we're currently also building support for WebGPU, and recently we also released a request for comments, or sort of an RFC for being able to actually run WebNN as a supported backend as well, which can directly use the native performance of these underlying hardware, right, and use them in a platform agnostic manner to power up your machine learning applications. So I'll quickly jump back into. I'll just stop sharing my screen and quickly jump back to my presentation. But again, I hope everyone is at least able to understand this part. So let me quickly just go ahead and quickly share my screen again. All right. So I've started sharing it again. All right. Great. So basically, this is what we are sort of looking at in terms of the API itself. And again, what now we are coming into is the actual delegate. So first, let's talk a bit more about what exactly is the scenario currently with TF Lite. So TF Lite, as you might be knowing, is another supported platform like TensorflowJS. So TF Lite is primarily focused on running lower end like sort of machine learning models on lower end applications such as mobile devices on some kind of lower end more such kind of lower end devices such as Raspberry Pi and all. So very recently within this year we actually got support for being able to run TF Lite models directly in web as well. So basically, that allows you to run a certain set of conversion steps that allow you to basically use your .tflite file format and then run it directly in TensorflowJS. So you can use your TFLite models and then actually run them directly in the browser with the help of TensorflowJS. So there is also something called as the Tasks API that is also released this year that allows you to basically utilize various different types of runtimes. So that includes basically a TF Lite, that includes MediaPipe, which is again another machine learning framework. Again, this might be sounding a bit more confusing than it should, but today just the ecosystem of machine learning in web is so huge that we are seeing all these interconnections of different kind of web standards, different kind of machine learning frameworks, runtimes, giving actually being given support in TensorflowJS ecosystem. So just to put it in a very small nutshell, just to understand this, the things that now TF Lite, which used to be used to actually run on lower powered devices on things such as Android and iOS and all, now can be run directly in web. So basically, there is this something called as the TF Lite delegate, and what it allows you to is allows you to basically bring in more different kinds of frameworks that allows you to use the native capabilities of again your hardware to basically run your models. So basically in the TensorflowJS SIG, right, which is the special interest group, a couple of different folks from Intel and Microsoft requested for a new support, and that is being able to utilize WebNN as a delegate for TF Lite. So what that means is that if we are able to support WebNN as a platform for TF Lite, we can essentially use that capabilities directly in the TF Lite web JavaScript API. And that is what is essentially this particular slide really talking about. That basically what we are doing is, if we just understand this entire flowchart, right, or this high level architecture. So at the top you have your web application, whatever web application that you might be running. Then let's say if it is a machine learning based application running on TensorflowJS with support of the TF Lite web JavaScript API, that means that we are utilizing a TF Lite file format based machine learning model, and we are running or powering our web application using this. We can use the WebNN delegate, right? And what that would allow us to do is that it will give us the capability of being able to run the WebNN delegate with, let's say, the the WebAssembly runtime that might be being used to actually run the TF Lite model, and that will basically give us support for being able to utilize the capabilities of WebNN and use that to gain some better performance, right? So basically that is what is going on behind the scenes, and we have this right now, as sort of we are seeing this. We currently have and I would definitely love to sort of give more insights into this, because this is sort of the brains behind what's going on right now. So I'll again just quickly share my entire window. So let me just quickly share that. So if it could be shared, that would be great. I think it should be shareable now. So all right, we are good to go. So first, just to quickly recap on the TF Lite support. So basically we are having the TF Lite, and again, as I mentioned, that we have this something called as the delegate that allows you to add more and more frameworks for support for TF Lite. So basically this is the RFC for the proposal, right? That sort of showcases how we can add WebNN as a potential delegate, which basically utilizes the web neural network API, which is basically WebNN, and it will allow us to sort of be able to actually do hardware acceleration of the TensorFlow Lite WebAssembly with, let's say, if you have some dedicated AI accelerators, whether it's like GPU or DSP. DSP's a digital signal processor. So these are some dedicated hardwares, right? And if you go more deeper into just understanding what exactly is going on right now, so right now we are at the stage where this has been requested for proposal, and the TensorflowJS team currently is actively, sort of supporting this particular use case, and we are already in that stage where we are sort of now testing it against some of the other runtimes as well, which I'll just quickly showcase. So again, the idea is that we are able to go ahead and utilize the power of WebNN API, right? That would allow us to significantly boost the power of being able to use your native APIs directly from your hardware acceleration, that will help you to go ahead and use that, right? So I'll just quickly go ahead and also showcase basically some of the API demonstrations that we have seen right now. So as you can see, specifically with this particular demonstration that was done, right? So what we are seeing is the TF Lite web API demo. So this is done using the WebNN delegate, right? So if you just compare against some of the other performance that we have, so for example, we have support for XNN pack WebAssembly SIMD. Then we have XNN pack that basically is using the TF Lite native, right? And then we have XNN pack based WebAssembly with multi-threading. Then we have the native WebNN CPU. We have the native WebNN GPU, right? And we also have the WebNN GPU with the TF Lite. So as you can see that for a particular machine learning model, we can definitely see the performance gains that we are getting. Again, we are comparing it for two very popular machine learning models. One is the MobileNet and the other one is ResNet. And you can definitely see the performance gains that we are getting by being able to leverage the native machine learning capabilities that is provided by being able to use some native acceleration for powering these machine learning models, right? And this just goes on to showcase that how powerful this particular demonstration would be, like if and when we actually introduce the WebNN support to actually power these models. So that just goes on to showcase some of this, right? And of course, now I would just want to show you some of the demonstrations directly from WebNN. So we have the site provided again by Intel, where we can sort of choose whether we want to use, let's say, WebNN, or we want to use, let's say, OpenCV. So, for example, I could choose one of the backends such as either WebNN, or I could use, OpenCV.js. And in this, let's say, I can choose, for example, let's say TensorFlow. So I could choose any of these given machine learning models. Let's say I choose the MobileNet model, right? And then I can give it basically these different types of backends that can be used to power, right? And it will sort of give you an inference time. Now, polyfill is actually one of the earliest versions of the WebNN. Of course, since then we are seeing native support for WebNN as well. So, for example, you can see that the inference time when we're using it with WebAssembly was 302 megaseconds, where it is basically using image classification model to provide a label to the image. So we could utilize some other image. Let's say we use this person, and we could try to see what's the inference again. So it's able to find that, hey, like there's a jersey within this inference, right? And if I try to use my live camera, let's allow it to use the live camera. All right. So as you can see that it is able to find things such as sunglasses, and it's doing live inference as well. Again, it's not 100% accurate. We can try to change and look at the different types of images and see based on the comparison on the different models that have been provided. But then we can compare between the different types of backends that we're running to sort of use. For example, it could use the WebGL or it could use WebAssembly, right? And so that's basically what it is doing right now in this, right? So you can go ahead and use this playground where we are sort of running this provided by Intel. Now going and understanding more deeper into some of the examples that have been provided by the WebNN API, just to understand where exactly we are today with respect to machine learning, right? So these are some of the examples or sample applications where basically which have been built with the help of WebNN API, right? So again, what you can expect is that whenever we get support, official support for WebNN, you could utilize them by creating, let's say, a TensorflowJS based application, and by running the WebNN as the backend to sort of power, right? So we have all of these. So for example, let's just try to use this image classification based model that we just sort of saw. So for example, we can use CPU in this case, and we could use the MobileNet model, and we could try to let's say use our live camera. So it's right now just waiting for the model to actually load. So as you can see, like once the model loads, then we'll be able to see it live in action. So right now, as you can see, that this model is using the WebNN polyfill based support. So one more thing to keep in mind is that this one that you're seeing is WebNN polyfill, which is actually a lot more slower. This is one of the standards that we currently have, but the one that we are sort of looking into is basically the WebNN TensorFlow Lite Web API. So that's one of the differences that you should be keeping in mind. So the one that we are currently seeing is basically this WebNN polyfill. Now this is one of the older standards, so this is not a new standard. Basically this is the one that was run previously, like it was built previously, and the performance of specifically the WebNN polyfill is somewhat lackluster. We are currently working on this the TensorFlow Lite based web delegate powered by the WebNN API, which will be much more quicker as compared to the one that we are currently seeing for the WebNN polyfill. So you can see the examples over here. So basically this goes on to show that even if you are just using WebNN outside of TensorFlow, we have support of actually being able to run a lot of different sort of examples and a lot of different applications that can be even built without using TensorflowJS. So this is a quick walkthrough of being able to, and of course you can just go ahead and also look at the code base that is actually powering these WebNN samples. And again, these are using the TF-Lite TensorflowJS based models, and this is what we are sort of going to be seeing much more and official support very soon as we are doing. So basically, just to sort of summarize what we have covered so far, is that essentially the WebNN standard that we have today, that is the Web Neural Network standard, will help to basically bring the machine learning within JavaScript close to native performance by being able to utilize your native hardware and native CPU, GPU, by able to access those via an API. That API is your WebNN API, and then being able to power your machine learning applications, right? And we're already seeing that by seeing such kind of performance gains as compared to some of the other other frameworks that we have, right? And of course, this will enable us to be able to actually build much more powerful machine learning applications directly in the browser as well. And of course, if you want to contribute to this space, there are three different ways. Today, you can join the TensorflowJS SIG, which I have shared in this particular slide. So we have basically these monthly meetings, usually on the first Tuesday of every month, where we discuss about things such as these. And recently, we also started with the a specific repository on the TensorFlow, which I just showed you, right? So this is basically the repository that we have, which is the SIG TFJS, where the folks who are in the TFJS SIG, they can create new proposals for, let's say, introducing new models, introducing new backends, and introducing new formats and frameworks as well, right? And that is what we are going to be seeing, right? So you could basically contribute to this SIG's TFJS repository and on GitHub. And of course, if you want to be a part of the larger ecosystem, we have basically the support. You could essentially join the WebNN. Essentially, you could join the WebNN. Let me just quickly go to that particular page, which is basically the Web Machine Learning Working Group, right? So you can even join this working group as well. So there is basically a community section where, again, what you're doing is that they also have these monthly meetings. So this will not be more specific towards TensorflowJS itself, but this will be more just to understand what's really happening in the entire ecosystem for machine learning within web, right? So this will be much more deeper into also being able to see how we are working outside of the TensorFlow ecosystem with things such as OpenCVJS, ONNX as well. So you could also join the working group and the community group for the Web3 W3C machine learning working group as well. Again, the links for these I'll just share at the end of this session as well. But yeah, that's pretty much what exactly there is. Again, there is not a lot to cover from a code perspective, because very specifically, I mean, with respect to the TF Lite support, it's still something that we are seeing right now. So we are pretty much at an early stage of creating some kind of usable diagrams, some usable examples, but of course would love to have, let's say, a follow-up session on WebNN when we are at that stage where people can actually start utilizing it as a specific dedicated backend, right, whenever you're utilizing machine learning models. But still, if you want to go ahead and look at some of the examples, basically this is a good website, or like this GitHub link is a good one to just look at some of the examples that we have today. So I'll also make sure to share this as well. So this is again by the web machine learning community, where we have a lot of these WebNN samples that are essentially using the web neural network API samples. Again, these might or might not be using TFJS, so just keep in mind regarding that. Some of them might be using TFJS, some of them have just been built using some of the other frameworks. So I'll share this link with everyone, just for everyone's reference. All right. Yeah. So I think we have already shared. That's great. So yeah, essentially that is what really is all about. What exactly is WebNN? What is the W3C Web Machine Learning Working Group? And it's essentially the parts of these working group that are sort of leading this effort right now. So I'm not sure if where exactly could I find it, but I guess it might be over here, where basically we have Ping, who is one of the staff software engineers at Google for the TensorflowJS team, and then we have Ning from Intel and Chai from Microsoft, who are sort of leading this web machine learning group, right? And they are the ones who are bringing in basically this request for support for adding the WebNN as so. probably I'm looking at a timeline of somewhere in mid of 2022 where we might have dedicated support for WebNN. But again, this goes on to showcase that today we have really reached at that point where machine learning for web is at a really advanced stage, right? We are able to build so many productionized applications. We are able to utilize all of this to build some really great applications. So right now is the perfect time to just jump into this bandwagon of being able to run machine learning models in JavaScript with the help of TensorflowJS. With that in mind, that sort of concludes my presentation. Again, if you have any questions, I'd love to take them up right now in this live chat. And of course, you can connect with me on my Twitter at the rate howdevelop. In case you want to, sort of go. I usually share a lot about TensorflowJS, some of the newer models, some updates, right? I love to share about that. So you can follow me on Twitter, or of course you can always message me on Twitter if you want any kind of advice on how to get started with TensorflowJS. There are a lot of great resources today that we have out there, and a lot of great community members, including a lot of folks from the TensorFlow user group members, including Shubham, Ali, and of course Karthike as well. So a lot of great folks who can always you can reach out to them in case you get into any issues, right? So with that in mind, thank you so much, and now I'll open up the stage for questions.
Thank you, Shivay, for a
Yeah,
fantastic
thank you so much.
session with us. It was quite insightful, and I am sure everyone took something away from this session. Yeah, there are few questions from the audience which I'll ask. Yeah, first one is from Subham Shah. He's
Yeah.
asking, does WebNN support JAX inspired WebML framework in libraries?
Okay, so Shubham, that's first of all a very great question. And as I showed you that currently WebNN has support for a lot of these TensorFlow.js, TensorFlow, and then Onyx, OpenCV. So I'm not exactly sure if there is support specifically for JAX. Again, just for reference, JAX is also like a separate category of machine learning within that comes under the ecosystem of TensorFlow, more specifically for scientific computing. So I'm not exactly sure if there is like direct support for JAX itself, but that's something that I can go ahead and look forward to and answer more. But again, personally, I am not aware if there is support because I haven't come across it as of now.
Thank you, Shivay. There is one more question from Saurabh Sone. Can we construct custom layers with additional activation functions on the top of WebNN API? And if we do, what is the scope for those custom layers? And will it include convolution normalization?
All right. So, sort of like basically, since we are talking about deep learning, of course, if we are okay, I'm sorry. All right. So if let's say we are building something on top of the WebNN API, it will give you that native platform to power up your application. So definitely there is possibility if, in case you're building your own custom machine learning model, let's say a specific neural network that you're creating, that will allow you to change the activation functions, allow you to add some more layers as well. So definitely that support is going to be there. And of course, depending on the neural network that you create, of course, you might get different performance based on how you're utilizing the WebNN API. So definitely there is support for that.
Yeah, thank you. We have one more last question. It's not related to this session, but I guess you will love to reply. This one is from Sekaran. He's asking how to be as awesome as you.
Well, I don't really have a great answer for that, but I would say just love what you do. I personally am really, sort of a fanatic for TensorFlowJS and what it really does for web. And it's really this, goes on to showcase that how WebSM, how machine learning today has really grown, right, as a technology, as a field of computer science, that we have a lot of different capabilities with machine learning, right? And of course, there are applications that might not utilize machine learning very specifically, but just the amount of support that we have today for machine learning just goes on to showcase. And if you're passionate about it, you can do wonders with it.
Yeah, that was a very interesting one. And we have one more question from Prathamesh. He's asking, since it's so deeply connected with the JS engine, would the engine's limitation be model's limitations, and how to overcome that?
All right, so this is actually quite okay. I think there is some correction as well made. Models
Yeah, there is one
performance.
more connections. Model limitations to model's performance.
Okay, the question is more specifically about JS engine. So this sort of sort of falls back into understanding how really JavaScript is compiled, right? And how, I mean, this goes much more deeper into understanding what really goes on behind the scenes with like whenever you talk about any web application, there are different kind of engines, right? So we have basically the V8 engine, we have some other smaller engines as well, such as I think I'm forgetting the name, but there is this one engine that has been built specifically for edge devices, right? So we have a lot of different engines, JavaScript based engines, right? So since yes, I mean it definitely makes sense that in case your engine itself is not a fully supported engine, there could be some kind of a limitation with respect to that. But of course, since we are still running native JavaScript and we are utilizing the native power of your hardware, right? That includes CPU or GPU. I don't think so. It will act as a major blockage. With the engine, of course. I mean, if there is no support for a particular backend with a specific engine, but normally, I mean, with most of the JavaScript engines that we see powering things in such as your most regular web browsers such as Chrome, Mozilla, they have support for different kind of sensor APIs, different native hardware APIs that you can directly use with them. Of course, this might be a bit more problematic if you're utilizing some of these smaller JavaScript based engines, but in mainstream, like if you're using some of the most mainstream browsers and engines, it will not be a problem and it will not be a major blocker.
Thank you. Thank you, Shivay, for answering these questions. And with this, we have come to end. Once again, thank you, Shivay, and thank you everyone for giving us your time on this Sunday evening.
Yeah,
And we
thank you so
really
much, Smith.
appreciate it. Thank you, everyone. And
All
take
right.
care. Stay safe.
Great.
Bye
Thank you,
bye.
everyone. Bye.